Hello everyone, welcome to the video lecture series on C programming language. We are in our lecture number 61. So up to our last lecture we learned about what actually pointers is, how pointers can be connected to arrays, functions, and we learned about structures, and also we learned how pointers can be connected to structures. And in the last video we learned about dynamic memory allocation functions like malloc, calloc, free and realloc functions, right? So in this lecture we will be seeing about what actually different types of pointers we have in our C programming language. So as of now you have learned about only single pointer concept. That means a variable can be converted to a pointer where that pointer will be holding the address of another variable. That is what we learned up to our last lecture. But other than the single pointer, we have double pointer, dangling pointer, null pointer, and void pointers also. So in this lecture, let us learn about all these four other types of pointers. So I'm not repeating about this single pointer, but if you want to learn about the single pointer, I'll keep a link on the above bottom bar here. You can get from here. Okay, so let us start with the double pointer. Double pointer is nothing but pointers to the pointers. So what actually the meaning of this one is, single pointer will be holding the address of a variable. That variable will be holding another value, but this pointer will be holding the address of that variable. Now pointer to pointer, which is called as a double pointer, will be holding the address of another pointer. Make a note of this one, all of you. So a pointer to a pointer is in turn is declared as with double asterisk, and it will be storing the address of another pointer, not a normal pointer. I'll show you an example here. I have taken a normal variable, int variable, and I have taken one pointer, variable px. So one star is given. That means this px is a pointer variable which can hold the address of another integer variable. In our case it is x. So we can write px equal to ampersand x. But if you want to store the address of px, then we need to have a pointer to the pointer which is represented by a double pointer. I have taken a variable called ppx. So if you want to store in this variable address of another pointer, then it should be declared with two star symbols, two asterisk symbols. So in ppx we can store the address of px, but in ppx if you are trying to store the address of in ppx we can store the address of px, but in this if you are trying to store the address of x, you will be getting an error. Why? Because we have declared ppx here which is capable of storing the address of another pointer only. So double pointer will be telling us like this. Okay, so px is a single pointer in this case, and ppx is a double pointer. Px is a single pointer which will be holding the address of a normal variable, whereas ppx is a double pointer which will be holding the address of a single pointer. Got it, all of you? So this is about pointer to pointer, and you can see the diagrammatic representation of this one. X is stored in a memory with a value of 10, and the address of this 1002 can be stored in px, and the px will be having some memory location, and the address of px can be stored in ppx. But we can't store the address of 1002 in ppx. That is not valid. Right? So this is about pointer to pointer which is called as double pointer. We have the other type of pointer which is called as a dangling pointer. Dangling pointer is nothing but, see, suppose we already learned in our previous lecture about dynamic memory allocation functions. Okay, so dynamic memory allocation function is used to allocate the memory at runtime. To allocate the memory we have to use malloc, calloc functions, and once your work is done you need to free that. Isn't it or not? But after the memory is also free, even if we are using that same pointer, whatever pointer you have allocated, then that pointer, then that pointer is called as a dangling pointer. So dangling pointer is a pointer which points to the memory that has been freed or deallocated. Okay, so a pointer which is pointing to a non-existing memory location is referred to as a dangling pointer. So in your program, if you have written free of some pointer variable, and still if you are trying to use that pointer, then that pointer is called as a dangling pointer. Okay, so if you are trying to access that memory using that pointer, then you may be getting an error called segmentation fault error. Okay, so if you see this simple example, we have allocated this memory using malloc. If you want to know in detail about malloc and calloc, free and realloc dynamic memory allocation function, here is the link for this one. Okay, now we have allocated some memory and we have written some statements. After our work is done, we have freed the memory using free dynamic memory allocation function. Now the whatever is pointed by this by p, that complete memory has been free. But after this, I have written one more statement where in p I want to store the value of 12. Star p, I am trying to access a non-existing memory location. Why? Because p is not existing now. We had made it as a free. So if you are trying to do like this, then you will be getting a segmentation error, and from this statement onwards p will be referred as a dangling pointer. Here is the diagrammatic representation, that one. So once pointing to a memory location that is used to hold the original object, normally it will be like this, but dangling pointer will be pointing to a deleted object. Normal pointer will be pointing to the objects already existing, but a pointer which is pointing to a deleted object is referred as a dangling pointer. Okay, that is about your second type. And the third type is null pointer. Null pointer is nothing but, suppose if you want to assign a pointer in your C programming language with a value of null, then we can go with this null pointer. Now how can you do that one? To initialize the pointer variable with a null pointer, you can simply write int star p. Suppose if you don't have any initial value, then you can directly give null. So to check for null pointer, we need to check for a null pointer before accessing any pointer variable. Why we need to check that one? Because we can handle some errors which may happen in future. You can see one example here. What is the example is, if you can pass a value, you can pass a null pointer value as a function argument, like this what we have done in this program, int star p. If you are seeing, what do you mean by here is ptr is nothing but the value will be null. So if you don't know what to pass, then you can simply pass the null value, or else you can write if the int ptr whatever pointer value, if it is null, then you can write some code, and if it is not null, you can write some code. According to your requirement, you can make changes in your program. So what we can say with null pointer is, null pointers are invalid, but still it is a specific valid pointer that is used for some specific purposes. Got it? This is about null pointer. Simply, if you don't know what to store in that pointer variable, directly give null. That's it. Okay, we have the other fourth category, which is about void pointers, which are also called as generic pointers. Now what is the use of this one is, if you don't know the data type of the pointer in what we are whose address you are going to store in future, in such a case we can declare that pointer as void. So a void pointer is a pointer that has no associated data type with it, but in future if you want to store, let us consider you have created one pointer called star p and you don't know whose address you are storing and what is the data type of that variable. In such a case, declare that variable as void. Okay, so a void pointer can hold address of any data type. Only thing you need to do is typecasting. What actually typecasting is, you already know about this one, converting one data type to another data type. If you are not knowing about this one, I'll provide a link for you here. You can go through that lecture once. Okay, so if you see this example, how a void pointer will be used, I have taken a variable called a and b, and I have taken a void pointer. Observe here, ptr is a void pointer. We have not specified it as a int, not specified it as a char. Now this void pointer can store the address of a and b. Suppose if ptr is declared only as int, then it is capable of storing only int variable address only. It can't store the char data variable address. Okay, so void star ptr if you are writing, then the ptr can store the address of a and address of b. But if you want to get the value, then we need to do the typecasting. How that can be done, I'll show you. See here, void star ptr is storing the address of a. It is a valid statement. Now using this pointer, if you want to access the value of 10, then in the printf statement here I have done the typecasting. See here, int star. If you write directly, let us consider if you write int star ptr, directly we'll be writing star ptr. But if you are using void star ptr, then you need to do a typecasting. That is what mentioned here. We need to do the typecasting. So int star a, in that case you will be getting the value of 10. Okay, now ptr is pointing to b, which is also a valid statement. Now if you want to get the value of b, you need to do a typecasting of star. But here make a note, all of you, see what is the difference. You see this example, b, a void, ptr is a void, and we are storing the address of a. If you write directly star ptr like this, you will be getting an error. Why? Because we don't know what is the data type of ptr. The ptr is holding the address of int variable. That's why we need to write like this, what we have done here. So void pointers cannot be dereferenced like this, the way it has been represented. This code will give you an error. Okay, so whenever you are using a void pointers or generic pointers, you can declare that variable, pointer variable, as void itself, and any variable data type, any data type variable address can be stored. But if you want to get the value, then you need to typecast that one. Okay, so these are all the different types of pointers we have in our C programming language. I'll repeat once again. We have single pointer, we have double pointer, we have null pointer, right, and we have dangling pointer, and we have the last one, that is about our void pointer, which is also called as a generic pointer. Right, I think I hope you all are clear with this concept. Okay, so with this we'll come to an end of our today's class. If you have any doubts, you can just comment me in the comment section below. Let us all meet in our next lecture. Until then, thank you all of you.